welcome. Good afternoon if you're joining us from somewhere in the Indian subcontinent. If you're somewhere in Europe, I guess an early good afternoon. And if you're in the North America region, as Todd has very kindly joined us from, a very, very early good morning to you. Just a couple of quick pointers for the attendees. You are in view and listen only mode. This is probably self-evident, but there's such a dearth of platforms that we're using that I thought it might be worthwhile to mention in case you're wondering why your browser hasn't asked you to access your mic and your camera. So we cannot see you. You can see us and hear us. The way we would love for you guys to interact with us is using the chat function, which is on the right-hand side of your screen. You can use that to send messages to everybody who is in the room, as well as direct it to any one of us, especially if you have any technical challenges. Feel free to shoot me a chat message and I'll do what I can to help you out. I will speak for about 10 or 15 minutes at max. I'm not really set up to answer any questions in that the bulk of what I'm going to be saying is going to be context setting. Todd and Yash will be getting into the meatier parts of the discussion today in the context of where the Indian automobile manufacturing industry is, as well as how remanufacturing in the automotive sector fits in. So I would encourage you to stay the entire length because I think it's going to be a fascinating learning experience as well as discussion. So one or two questions after Yash and Todd speak respectively, and I'd encourage you to put those in the chat, and you can save the rest of your questions if you would. That would be terrific towards the end. You're welcome to include the questions as we go along, but we'll do our best to get to most of the questions at the end. The webinar is being recorded, so in case you do have to jump off for some reason, fear not. We will post the recording within the next week. But we very much encourage you to stay because when the recording is posted, there's no interactive Q&A. So this is really an opportunity to be part of the discussion as we're going along. So our speakers for today, I am very, very pleased to have Yash Pal Sachar and Todd Wieland join us today. Yash Pal Sachar serves as the chairman of the Aftermarket Parts Group at the Society of Indian Automobile Manufacturers. He has been in this role for the last 5 years. He's also the general manager for corporate affairs at Honda Cars India Limited. He has over 30 years of work experience and has worked with various automobile and consumer electronics multinational companies. He has expertise in the areas of sales, supply chain of service parts, and corporate affairs. He is a mechanical engineer by training, which is great because so am I. And he has an MBA from the Faculty of Management Studies at Delhi University. So welcome, Yash. And our second speaker for today is Todd Wieland. Todd is joining us from Indiana, from the city of Columbus, which is south of Indianapolis, very early in the morning. Todd is the Director of Research and Technology for Cummins New and Recon Parts, which is the division of Cummins that specifically looks at remanufactured products. He has responsibility for developing products, processes, and technologies for remanufactured and new aftermarket parts. He leads a global team and an R&D center dedicated to aftermarket needs. Todd has been involved in remanufacturing for over 15 years now, including global reman engineering leadership, new plant startups, and new business development. He participates in making new product designs remanufacturable and in framing sustainability goals for Cummins. He is a board member of the Remanufacturing Industries Council in the US and chairs the Research and Development Committee at the Council. His career includes leadership roles in product and materials engineering, additive manufacturing, design and simulation at Cummins and elsewhere, and was a US naval officer before joining industry. So welcome, Todd.
Thank you.
All right. So I want to just very quickly run through the agenda that we have set up for the next 90 minutes. You'll only hear from me for the next 10 or so. Following that, Yash will share a perspective on or a current state snapshot of the Indian automotive industry, which has seen, like many industries, a very interesting last year. Following that, we'll hear from Todd, who will give us a sense for the remanufacturing point of view in India. Cummins has two facilities operating in India. Cummins has also been in the remanufacturing business for a number of years, so it will be a fascinating point of view to get a sense for how this works as a business model in given the operating and other circumstances that we have in India. Following that, roughly at about the hour mark at 5, we will switch into a discussion in Q&A where really you have an opportunity to pose your questions, and also we will discuss amongst ourselves anything that emerges by virtue of having learned what is shared during the presentation. So very much encourage you to stay towards the end, because this is going to be in some ways a lot of the interesting and the movement forward kind of conversation emerges when we step away from the script of presenting and just talk about ideas. My goal is to wrap up by 5:25 or 5:30 at the latest, and I will do my very best to keep us on time and on track here. So that being said, how did we get here? What I want to spend the next few minutes on is just talking about context and where we are from a very bird's eye view of the evolution of the auto industry. This particular graphic that you're seeing is derived from the strategic intelligence platform that the World Economic Forum has. And WF really identifies 6 key elements or factors that are shaping the automotive industry at large. Of these 6, business model shifts, emissions and pollution, and market divergence really I see as being the most pertinent to emerging or developing markets like India. From a business model shifts perspective, there's a broad movement from ownership to a transportation experience. Looking at shifting demographics, we're seeing that millennials have a lower rate of car ownership. And also there is a greater movement and growth of sharing economy related mobility services. From a, emissions and pollution standpoint, this is common knowledge at this point. Climate change and air pollution really are big pieces of the shifts that are happening across the board in mobility in general, not just in the auto industry. And the circular economy is part of that transition for sort of looking at it from an economic architecture perspective. How do we move towards a model that gets us to those goals of sustainability, coupled together with technology shifts, etc. And market divergence is really the fact that demand is shifting to emerging markets, India being part of that emerging. And it provided a really good framing of some of the driving forces within the auto industry. It was a study that surveyed executives in the hundreds from the auto industry as well as industry experts. And there were some key points that I thought were relevant, which are both driving factors as well as in some ways provide the clues towards the path forward. One of those being, again, related to climate change is transportation accounted for about a quarter of the world's global CO2 emissions, and road transportation alone accounted for about 18% in 2016, which is fairly substantial. Non-biodegradable waste from end-of-life usage as well as manufacturing contributes to landfills, land toxification, and water pollution. And from a life cycle standpoint, production of vehicles takes up a fair amount of resources, energy, water, resources, which when you take that and layer it across the life cycle and also look at the carbon footprint, all of that adds up to be quite substantial as well. what the report or that research also found as conclusions is that within the auto industry, sustainability is being looked at as a strategic issue, um, and almost to the point of part of organizational purpose. So it's no longer at the periphery. It is very much front and center in terms of how companies are moving forward on sustainability actions, and also how they see themselves and what that relationship means to their consumers and stakeholders at large. Not surprisingly, sustainable R&D and sustainable manufacturing, which is closer to the core of what the industry does, receives greater attention from companies. And two critical areas have been identified in terms of driving maximum sustainability impact in the industry. One is ensuring that electric vehicles are truly sustainable, and the other is incorporating circular economy practices across the value chain. And this is really where remanufacturing fits in. Look through that circular economy point of view. And I want to quickly talk about what remanufacturing is. Many of you may already be familiar with it, but as we are, part of the work that we do is sensitization about remanufacturing and also clarifying what it is and what it isn't. And I think there's some utility in reinforcing that messaging every time we have an opportunity. So from a process standpoint, when a product like an engine or something as small as a starter or a brake caliper reaches the end of its useful life, from a process standpoint, going counterclockwise on that diagram, it involves the collection or reverse logistics of that product, preferably done in a formalized kind of way to ensure that the product is cared for so that value is retained, it's not damaged, etc. Following that, it's brought back into the industrial environment or industrial loop where you have processes or steps like disassembly, inspection, and then repairing, upgrading, or replacement of parts that are no longer functional. Following that, it follows a very similar path in terms of traditional manufacturing in that you're assembling, coating, finishing, performing the requisite quality tests, and the product enters the supply chain back again, either going back to the original user, say if it might be through some kind of lease-based business model, or it can end up with a new user. And I intentionally started with the process because the process gives you some context to the definition, which is to say it's a comprehensive and industrial rigorous process. You're looking at bringing products back to a like new or better than new condition from a quality and functionality and performance perspective. And it's a controlled and reproducible and sustainable process. That's really what is defined as remanufacturing. This is from the American National Standards Institute standard that was published in early 2016. The standard is dated 2016. It was finally issued in early 2017. And in talking about remanufacturing, it's also worthwhile just talk about what it isn't. There sometimes is this danger that words that have a re before them, like recycling, reusing, repurposing, they all get lumped together. And so remanufacturing gets lumped into that. And so it's some kind of recycling activity. And this is completely not true. Remanufacturing is extremely specific in terms of what it does. There are standards associated with it, and you're looking at bringing a product back to a functional and quality level, which is as good as new, if not better. So it is not recycling, which is typically understood to be material recovery, reusing, which is essentially giving a product another life cycle without any major intervention, not that either. Certainly not repurposing, where you're looking at a different purpose or use altogether. Repairing comes close, but it's also not the same thing. Part of it is the quality that you get at the end of it, as well as the warranty that's assigned to the product. Remanufacturing sometimes is interchangeably used with refurbishing and reconditioning, not necessarily in a broad kind of way, but there are some industries that use those interchangeably. I am a bit of a purist in that I stick to remanufacturing, especially because there is that ANSI standard that puts a clear stake in the ground as to say this is what it is. And so there's clarity in sticking to that and value in that, so not to confuse what remanufacturing is with other elements of that circular economy closed loop model. From a global standpoint, These are statistics from a study that was done earlier in, I think it was 2019, and published early this year by KBC and Rematech, which surveyed participants attending a conference, a remanufacturing conference, and so this was, direct feedback from industry incumbents, and to give you a sense for what the size of the markets are in Europe and Asia Pacific really are kind of at the top. And passenger cars and heavy trucks also are the dominant sub-segments within the auto industry that where remanufacturing occurs. From the standpoint of where or which product categories remanufacturing occurs in, as well as which categories are likely to grow over time, the figure on the right clearly shows you that given the growth of electric mobility worldwide, the projection is that electronic components, ECUs, electric and hybrid drive units, batteries are really where a lot of the market is going to shift as time goes on. But that's looking at probably several years. There still will continue to be remanufacturing occurring in traditional automotive markets. And really that's where, from a transitional standpoint, in trying to hit sustainability goals, carbon goals, or carbon emission goals, remanufacturing has some real value and utility in being looked upon from that standpoint. There are benefits to remanufacturing, energy conservation being one of the most significant, especially from the standpoint of looking at, again, across the life cycle of products. Things like resmelting won't be necessary if you can keep a part that's already been formed through multiple life cycles. Same goes with raw material conservation. And I'm running through these fairly quickly because you will get to hear in a little bit more detail some of these elements from Todd. But what I'm trying to do is to give you kind of a big picture, and then the details will get filled in as Yash and Todd share their presentations as well. These are direct quotes from the Automotive Parts Remanufacturing Association. One of the pieces also is air pollution reduction, again, related to the life cycle side of things, where, going further back a few stages in the life cycle has impacts. Electric mobility is really where you're going to see localized air pollution reductions by virtue of the switch to battery-powered vehicles. From a numbers perspective, studies have shown that 50% of a starter can be recovered. Again, looking at it from a totality standpoint, in the US, that equals about 8 million gallons of crude oil being saved in steel manufacturing, over 50,000 tons of iron ore, 6,000 tons of copper and other metals. So really, there's it's worthwhile to look at simply from the standpoint of what can be mitigated and how something that already has embedded energy, labor, cost built into it in a particular form and shape can be given multiple life cycles without compromising quality. Rebuilt engines can require 50% less energy and 60% of the labor required to produce new engines. From a labor standpoint, it's worth sort of considering also that while there might be labor reductions in one side of it, there can be huge job growth and employment opportunity from the standpoint of the reverse logistics that come into play, as well as the disassembly elements that come into play from the standpoint of being able to remanufacture. Remanufacturing certainly isn't a panacea, and I don't want to give you just a rosy picture. There are challenges that come or are part of it, including the technology challenges that come with shifting technology, especially in relation to electromobility. Pricing also is something that factors in significantly, especially in terms of getting economies of scale, bringing in more cores back. And so core essentially is a part or product that's reached the end of its useful life. And so in remanufacturing industry terminology, cores are those end-of-life parts or products that are then brought back into the industrial loop to be remanufactured. And in that sense, availability of cores, competition for cores, the quality of the cores that are being returned, all of these factors are challenges. And how this gets implemented in India, some of it we'll hear from Todd on how it's already being done. But from a future standpoint, these are considerations that will have to be looked at closely, especially in terms of reverse logistics and formalizing parts of that reverse logistics chain. From India, from a perspective of where things are in India, it's the 5th largest market in terms of auto sales in 2019, 7th largest manufacturer of commercial vehicles. And I'm not going to get into the details here, but this is really the part of the presentation where I pass it off to Yash, who will give us more details on what the state of the current market is. Cummins and Volvo are really the 2 companies that are known to remanufacture in India. That doesn't mean that there are more. This is based off of what we know on research that's already been conducted from a few years back. In terms of shifting tides and shifting perceptions on the future of development and economic or sustainable development and growth, there's been a lot of work that's been coming out at the federal policy level over the last couple of years, ranging from the resource efficiency and circular economy paper that was published in early 2019 to the draft national resource efficiency policy and the steel scrap recycling policy, which were both put out last year, as well as most recently the EU-India Joint Declaration on Resource Efficiency and Circular Economy, which was issued in July of this year. So there's a, these broad sort of movements are happening towards circularity and sustainability, from a macroeconomic or a macro perspective. Specific to the electric mobility side of things, there's also a lot happening. On this particular webinar, we're not going to go deep into electric mobility. Our plan is to address electric mobility as a separate topic altogether, or a separate discussion altogether, because I think that can easily take up a 90-minute conversation. So my goal really, I know I went through this fairly quickly, my goal really here was to frame this, where things are in terms of global shifts in the automotive industry, shifts in market expectations, as well as the increasing movement towards circularity and sustainability, not just in India, but across the world. So I will pause here and I will pass it on to Yash, who will give us a little bit more in terms of what's happening in India from the perspective of the Society of Indian Automobile Manufacturers, as well as his own point of view. So thank you for your attention, and Yash, it's all yours.
Thank you, Rajiv. Good evening to participants from India, and maybe it may be early morning in some part of the world. So good morning to you. So thank you so much. You have set the context. I will move to my part of presentation. So this is me, Yash Pal Sachar, and we are going to talk about circular economy and aftermarket perspective of snapshot of Indian economy. If we look at growth and recognition, so in two-wheeler, India is #1 in the world in terms of numbers. Similarly, for three-wheeler, we are #1. And for passenger vehicles, we are growing and likely to become #4 soon. And similarly, the situation of commercial vehicles. So this is in last, say, 2 decades of something like 8% CAGR. There's this change of regulations, cost of cars going up, and something like price elasticity. The sales volumes have come down, and this year further, considering the COVID-19 situation, we are expecting that the overall sales figures will be almost equal to what it was 10 years before. So a tough situation. Yes, it will take few years for us to recover, and while 3.4 million per year. So this was maybe for Todd or some people who are a little less aware about India. Then coming to this chart, we have tried to capture what is the kind of national perspective. So although I will say that industry is bouncing back, but how it looks like. So if you see the overall world economy, uh, somewhere same time last year, the world economy was supposed to grow at the rate of 3.6%. In April, some part of world were already impacted. So in the global economy was supposed to degrow by 3.0% or so. And as we were moving further in COVID era, so it became close to 5%. But yes, of course, now the things are becoming better at 4.4%. On the contrary, the Indian economy, which in the beginning of the year was still hopeful of 1.9% growth, positive growth, is now expected to degrow by almost 10.3%. We had a lot of lockdowns now in the era of reopening 5. We have also shared how the growth is reflected by in terms of collection of taxes. So September was almost little higher than what it was in last year September. On automobile sector, which I come from, in the beginning of year, April, the projections was 2 to 3% growth, which became almost 24% degrowth towards June. So now again, personal mobility getting good support. In maybe people want to be safe, they feel safe while they're driving their own cars on two-wheelers. So situation is again changing. This is the kind of sinusoidal kind of thing, and now at least a few of the manufacturers we're talking about a positive growth even. Last month, September, was almost 31% plus as compared to year before. So on regulation front, this is very interesting and related to this topic. So on regulation front, while we compare Todd in US, Japan, they are close to 4,000 to 5,000 kind of regulations. What to sell in market that is getting also regulated in India in terms of quality standards. So a lot many regulations now are there. They are related to safety aspect of which is a big concern. We are among the highest in terms of fatal accidents. So you can see what was mentioned for electric mobility starting from FAME 2. A big change is coming, a scrappage policy, which I will talk about more in detail in my subsequent slides. Moving further, as I said about end of life vehicle policy. So to give you a perspective, in India, almost the various studies done. There are, as of now, no regulation. Of course, this policy talks about voluntary scrappage policy from a mandatory policy which was discussed for many years. So the situation is there are a few vehicles as old as 30 years, 40 years. And when we do an analysis, we find that maybe 7.5 lakh of 750,000, say, commercial vehicles contributing to a good chunk of pollution. So yes, something has to get deregistered in terms of the pollution scenario which we are in. India is, as of now, Delhi, like in winters, known to be the pollution city in the world. So this is the very good big initiative for auto industry. When I say, as you rightly mentioned, Rajiv, there is reuse, recycle, different words are there, and remanufacture. As of now, this name itself doesn't exist in regulation context. So to give you a perspective, I was talking today morning to a very senior government official representing the Bureau of Indian Standards, BIS. So he also realized and appreciated, yes, of course, this area is still neglected, not even touched. So maybe we'll connect you with them so that you can explain more in detail. And thankfully, you have brought this very good topic first time. So for when we talk of end of life vehicle for automobile, it will bring lot many benefits besides environmental benefits. We are expecting it will help us in creating demand. Import almost close to 10% of our steel from overseas. Yes, lot many things has been done in last 2 or 3 years with efforts from government, from industry. Maybe if it was earlier 20% imports of the total steel used, maybe now it is say 10%, and there are further efforts to make it half in next 3 years. There are lot many precious materials which which will cease to exist. So better availability of those material is one such benefit which will accrue from end of life vehicle. Cost of vehicle will get reduced, and of course this is a big industry, will create lot many jobs. So we are trying to depict this from this picture, maybe for an easier understanding. So if you see on the block, second block, which is shared, the thing starts from mining to processing and final raw material, moving on to manufacturing of cars, going to dealers, and post this end of life vehicle. As of now, there was no such rule. So those are now getting framed under ELV. We are thankful to government that yes, although there is a delay, but yes, as of now, we are hopeful that anytime this policy will be announced, and these recycled parts will again through recycle, recover, will get moved to final raw material. So something like this will give to auto manufacturers a benefit in cost, so almost 4 to 5%. We are talking to become a global manufacturing hub for auto, for many other sectors. So it increases the competitiveness of India as a manufacturing hub compared to its peers, other countries. So a market of almost 43,000 crores, that's a kind of business it will bring. And if you look at, you must be hearing a lot many scrapping centers are being planned, not only from established OEMs, but also independent agencies that are also coming up and setting up this as a venture. If I say in India, as of now, still something in terms of numbers, to my guess, some 70 to 100, still in 2 digits, number of ELV centers are being proposed or have already come up. While I compare it, say, with the country like Japan, where this journey of mobility started a little earlier than us, close to 3,000 scrapping centers exist. So while we will be moving this raw material to OEM suppliers and bringing betterment, we say this is the right time to aligning with the vision of government to make ourselves a global hub of manufacturing. So this was just the beginning of these words, whether it is recycle, reuse, or remanufacturing. So I will relate this further through this slide, while I say remanufacturing, so there are certain aspects connected to this. As of now, the challenge for Indian automobile after sales is there is no quality regulation for what is being sold in aftermarket. So first pillar of this will be quality. Of course, it will be covering safety aspect also. So this is first to be addressed through rules, through recognitions. Recognition means remanufacturing should be considered as a business line, and not many regulations and not many appreciation has to happen for this sector, for its future contribution to reduction of imports, future contribution for making India more competitive. Secondly, while we say vision given by our Prime Minister Modi, Make in India, so there are this itself is creating another big opportunity for Make in India. Now I will relate this to aftermarket business. So aftermarket business, of course, has two aspects. One, we call it as current models, the models what are being sold. And as we are becoming higher up in terms of numbers, there will be a big fleet of old, non-current, discontinued models. So the challenge for aftermarket is how to address the aftermarket demand for those discontinued models. So to give you a perspective, I as a designer, when I will design a car, I will design a transmission for say 10 lakh kilometers. So 100,000 kilometers. So if after say 2 lakhs, 3 lakhs, there is a situation that one or two parts may get worn out and it needs replacement or making. We visited to see the supply chain of Honda cars. There lot of opportunity was there for remanufacturing of transmissions, engines. For non-current, this was furthermore understandable because you do not want to stock all of them to be available while the need arises. So, as was mentioned by Rajiv, from a definition perspective, but also to address a business challenge, which otherwise is very tedious. It will become so difficult that you cannot service those cars. So those are getting addressed through this remanufacturing. So I understand as of now in India, thanks to Rajiv to bring this topic for discussion. Maybe it is a well-established business line in US. I heard more than 50,000 crores of 10 years before. It was an established situation for say printers. So although no regulations, but yes, some kind of industry initiative, and it was established. So with this, I give back to Rajiv for further proceedings. And my understanding is maybe 20 years before, they must be having a similar situation what we are in today. Some standards must be getting framed. Some discussion must be having quality standards laid down for this remanufacturing. This situation, as a leader of Remanufacturing Association, you must have put in efforts. So while you will share your journey, it will be your life journey, which will become for us it will reduce the time to travel. If
Sure.
we can learn, so maybe that 20 years you must have spent, it becomes 5 years, 7 years for us. That will be a kind of help, kind of our very much.
Very good. Thank
Thanks,
you,
Yash.
Yash. Thank you, Rajiv, as well, for setting the context. That's helpful. Okay, so I'm Todd Wieland, and I'm really happy to be here to talk to you about remanufacturing and its connection to sustainability and circularity. I'm based in the U.S. I lead the global R&D team, as was mentioned earlier. I've got excellent colleagues in India, and I know that they will be able to continue the conversation with you on this. But what I'll be able to do is provide a little bit more of a global and historical perspective. But now we support alternate fuels and more recently electric and hybrid powertrains. In order to do that well, it requires a variety of components. These are complex systems, and so you can see the list of component types on the right-hand side there: filtration, fuel systems, after treatment, and understanding those and integration of those effectively has enabled us over the last decades to reduce particulate and NOx emissions by over 96%. If you think about it, that's a tremendous reduction in the emissions level of these products. And for NOx, we're now even supporting a further 10x reduction. So this is very significant. And then on top of that, right, there's a shift already happening toward electrified power. And there are some applications like urban bus where that makes sense, that is economic sense right now. And that shift will continue as the technology improves. Well, you can see the numbers there to give you an idea of the size of Cummins, about $24 billion last year. I'm also glad to be part of an organization that really emphasizes corporate responsibility in really three areas: education, a little bit more about also commitment to the environment, and that I know that this comes from the heart of our leadership, and it's really been part of our history. We are organized in those 5 divisions, as you can see down at the bottom. Let's put some numbers to that now. We're in about 190 countries, 60,000 employees. Last year, we built over 1.4 million engines. We largely own our distribution. We spent about $1 billion last year. We started in diesel in 1919 and remain headquartered in Columbus, Indiana. We've also been remanufacturing for a long time, over 50 years. And we support all those same markets where Cummins supplies new products. Let's take a look at the products. There's a whole list here, but let's look at those a little bit more. So engines. We remanufacture engines. What's the context there? A couple. One, there could be a failure, a catastrophic failure, where it makes economic sense to swing the whole engine instead of repairing it. Or there are other applications like a mining truck that will easily consume 4 engines over its lifetime. And so now we're not just talking about remanufacturing kind of as an option that a customer might consider at some point. For some applications, it's absolutely expected to support that high value asset over its life cycle. The other kind of things you'll see, cylinder heads and turbochargers, connecting rods, those will be parts typically used for an overhaul. Let's say the truck is at midlife, the engine needs to be refreshed, and so this will be an overhaul event, and those components then would be replaced. There are others in here, like a fuel system, a fuel injector in the lower left. Those are small, but they're high value, high precision, tolerances on the order of microns. They tend to have significant surface engineering, specialized coatings. And these things have, a tough life. They're operating, 17 hertz, operating well above 2,000 bar pressure, and they might need to be refreshed at some point during the life of an engine. And so those make a very good remanufacturing sort of candidate. And then in the lower right, you're starting to see some newer products, transmissions, automated manual transmissions, as well as electrification hardware. Those images are for very large batteries, but there'll be other components as well, traction motors, power electronics, that will be remanufactured as well. We do this around the world. The red circles represent our remanufacturing plants for our smaller products. The core is returned, we call that reverse logistics, right? Where that core that used the old product has to come back. We've got reverse logistics core centers around the world represented by the black circles. That's sort of the collection points then for the core that is then shipped back to the remanufacturing plants. The larger engines, of course, are heavy, and the transportation is expensive. And so we tend to handle that more on a regional basis near large populations of engines, and those are represented by the blue circles. We've been remanufacturing in India now for about 10 years. We've got an export plant in Pithampur where we produce both heavy duty and high horsepower components listed there. We also have a domestic plant on the Cummins mega site in Fulton, a couple hours away from Pune. And there again, we're focusing on the heavy duty and high horsepower components. Those are supporting both the India Parts Distribution Center as well as the high horsepower engine remanufacturing center. Rajiv provided a nice overview of the process steps. I'll go through those real quick again, but highlight a few of the technologies that we've developed along the way to facilitate that. I mean, the first point I'll make is, again, this is a factory-based process. These steps are typically occurring on a small line as opposed to some benchtop process. But it begins with disassembly. And you can appreciate that these products are operating for a number of years in environments where they may be exposed to road grime or other sort of dirt, can be some external corrosion. And so simply taking them apart can be difficult. And so we've automated and applied some technologies to facilitate that. Next is cleaning. The same challenges are part of cleaning as well. We've got aqueous methods, thermal methods, even molten salt methods to reduce the corrosion, the residual sort of oils and greases, the dirt. And the technique that you're seeing down below there is laser cleaning, a wonderful process. The laser ablates whatever the debris is, and because the clean metal underneath has higher reflectivity, the laser doesn't keep going, but stops once it's removed the debris from the surface. The next key step is inspection. We have to establish that the now clean core doesn't have conditions that would interfere with its next service life or that require repair. And so we've got various optical and other type methods to inspect the core. Next comes restoration or salvage, and there's a variety of things that we do there. There could be mechanical means for inserts, sleeves, bushings. Then we've got material addition technologies, thermal spray to build up worn surfaces, or more structural methods, traditional welding, or more advanced welding, like as in effectively laser deposition, where again we can build up that worn surface, and because we can choose the material often, the resulting surface actually can be better than the original. right? If a cast iron component was the original part, then that wear surface is cast iron typically. Well, here we can choose something that's even more wear resistant. And so arguably the remanufactured product is even better than new. And then finally, we've got the assembly and testing step, where we will typically use a version of the original process. We certainly have and apply the original specification, and then we can apply the same or similar test method as well. So why does Cummins focus on remanufacturing? Maybe another time we can talk more about the history of remanufacturing within Cummins, but I'll say a few quick words about that here in a moment. On the left-hand side, though, from a customer's perspective, availability of remanufactured products reduces their total cost of ownership. The next slide will dig into that a little bit more. From a Cummins perspective, it helps us manage and support the customer over the life cycle. Early in life, remanufactured products may be used to service warranty. In the middle of the life cycle, we may have the competition coming on the scene. What we call those will fits, value, price. Then remanufactured products can help meet that need. It's same as new warranty, same as new performance, same as new sort of global sales and support, sales and service support, but at a value price. And so that gives those customers exactly what they're looking for. Then late in life, it also helps us support our customers once the original suppliers, due to the loss of volume for that particular part number, may become expensive or may be not so interested in continuing that supply, right? So remanufacturing can help us support the tails of the life cycle. And we'll support our products, for literally decades, right? We would still remanufacture various components for 40-year-old engines. Increasingly on the right also is the connection of remanufacturing to environmental sustainability, and we'll talk more about that in a second. So first, from a customer perspective, what's the value proposition for remanufacturing for fleets and others that are very sensitive to uptime? After all, this asset is used to earn a living, right? And if it's down, being repaired, well, then it's not making money for the customer. And so swinging an engine or swinging that major component with a remanufactured one is just faster, and it's a way to get that asset back to work. Because it's a factory process to the original specifications, in our case, the customer is also confident in the quality, right? So this is a factory process, and the core terms vary a little bit around the world. Maybe we'll get to that a little bit in the Q&A, but the idea is we make it simple. Purchase the product and return the core. So at the bottom line, the graphics at the bottom help illustrate then the process. That core is returned. We're able to apply original factory methods. We've got the original factory specifications. We apply advanced technology, supplement with genuine parts, and produce that very high quality product. Okay, let's start to pivot a little bit toward the sustainability and environmental perspective using some numbers from India. First, in the upper left, easily 75% of an engine can be remanufactured. We've got lots of high value iron and steel castings and forgings that are good candidates for remanufacturing. Going all the way to the lower right, over the last years in India, we've recovered over 10,000 tons of core, producing over 500,000 different units, shown there in the lower left. Okay, so what difference does this make? Well, first of all, bottom center, this takes a lot less water compared to the extraction and processing of ore and making new castings and forgings. So we think we save 150,000 kiloliters of water every year. And water matters to us. We operate in water challenged areas, and we know as we think about the future that water will become increasingly one of those constrained resources. The other thing is that not having to recover that ore and reprocess castings and forgings saves a lot of energy, with the result that there's less greenhouse gas emitted. There are a variety of studies, by the way, with varying degrees of material reuse that describe or that help validate some of the numbers that you've been seeing. I think Rajiv mentioned a 50% sort of energy savings in the one case, and there are other analyses that show that number is even higher. Okay, continuing our pivot towards sustainability. Cummins is just finishing up a decade of largely meeting or exceeding sustainability goals relative to our own operational footprint. By that I mean the waste that we produce in our facilities, or the emissions from those facilities, or the energy consumed by those facilities. But as we look to the future, we recognize that, okay, we have to continue to do a good job there, but even more. And so here we've got inputs to the planning that was done recently for the updating of our sustainability plans, and you can see them there, right? And some of them you can appreciate maybe firsthand. So pollution is a growing concern. Climate change is real and it's happening. We get extremes of weather, flooding in one case and drought in another. And population is growing, and along with that growth comes increasing waste, and then also just in general resource consumption. And we anticipate that we have to decouple, or society needs us to decouple population growth from resource consumption. We just can't consume at the same rate that has been done historically. So what did we do with this? First, let's talk about our 2050 aspirational targets. They're really in three groups. At the left, we've got the goal of communities being better because we are there. That's a significant statement. Sure, we enable employment, but there's also impact in the community or in the environment locally, and so our goal is for the net effect of our presence to be positive wherever we're operating. And in the middle, we've got to do our part to a temperature rise to, say, 1.5 degrees Celsius. Then what we have to do is back calculate what the transportation contribution to that is, and therefore what reductions we have to make in our product portfolio to support, limiting that temperature rise to, again, whatever the scientific consensus is. And that's what we mean by science-based goals in a more absolute sense. But what I'll talk most about will be the third category there, resource stewardship, using materials in the most sustainable way. And so by 2050, we want to say, look, nothing's wasted. We design it out in the first place from products and processes, or we use it again. And again, we see water, the idea of using what we need, but returning it clean. Talking about 2050 is fun. Some of us won't be here, or at least not working on it. But closer to home, we've got some 2030 goals. Again, in sort of the three groups. At the top, we've got those climate-related goals that I talked about. At the bottom, we've got some of those waste-related goals. But in the middle is the idea I want to talk about, and that is creating a circular life cycle plan for every part, to use less, use better, use again. I was the advocate for this concept of the life cycle plan for every part. It can be difficult to convince a designer to prepare for remanufacturing. They may ask, well, how do you know you're going to reman that? Or what will the volume be? And those are reasonable questions. But on the other hand, we have to be more thoughtful if we're serious about these kind of goals at the front end of the product design, and say, hey, what's the plan for this product? So it seems to me that that's a reasonable starting point. And then oftentimes remanufacturing will be part of that plan and answer. So what does this really look like if we talk about a life cycle plan for every part? I appreciate already the discussion of the various R's, but I'll talk about them a little bit again. If we're talking about reducing, then obviously we can use optimization tools to only put material where it's needed. And, modern computer tools enable us to do this quite effectively. And we can choose material and processes wisely based on the planned usage cycle. If, let's say, there's a gasket that's really going to be replaced at the time of service, well, then that doesn't have to be designed for 1,000,000 miles, right? On the other hand, that major casting or forging does. We can also produce less manufacturing waste in the beginning using additive manufacturing. In fact, we're doing that now already. That is 3D metal printing to support legacy parts when perhaps, as I mentioned, the original supplier is no longer available. Okay, well, when the customer is first using the product, we're in the reuse and repair sort of mode, and so for that case, we want to make sure those wear points are durable or readily replaceable. Sometimes an insert or a bushing is all you really need to protect that more expensive casting or forging. But then at the end of the first use cycle, then remanufacturing would be relevant, and the idea there then is to design those high value components to have sufficient life for multiple use cycles. We want to plan for the material replacement, make sure the methods are available, defined and validated in anticipation of the remanufacturing. And at the end of the multiple use cycles, when we get to the end of life for that particular product, then we're in the recycling mode. And there we'll want to plan for material separation. That can be one of the challenges for recycling. And then be thoughtful about how we do it. For commodity materials, irons and steels, probably makes sense to plan for recycling of those locally. However, for constrained or more strategic materials, it'll make sense to recycle those centrally. And in fact, extract those materials and return them to our supply base. And we're doing that now with exhaust system components, for example, that have platinum group metals. Last year, I think we returned about 1 million pounds of those. Wrapping up here, let me reinforce first about what remanufacturing is on the right-hand side. So again, I think we've already seen this quote from the ANSI Reman standard, which is available via the link shown at the bottom. But the point here is this is a complete, it's a comprehensive industrial process. That previously worn product is returned to a like new or better than new condition, and that's going to be warranted. For us, it's going to be at the same performance level and the same warranty as a new part. So we are restoring the expectation of a full second service life, could be second or third, fourth. It's not a limited scope repair. It returns a saleable product to commerce, typically sold to a different customer. It's a product, not a service. And then importantly, it retains the embodied energy. We're not reducing the material to its to the sort of raw level. So you can see on the left the various material loops. You see the sequence of operations to produce it originally. You see the original sort of use cycle where we're repairing and reusing. Next comes remanufacturing. And then finally, ultimately, we get to the recycling stage. I do want to comment briefly. I do appreciate the end-of-life vehicle sort of perspective. There certainly is a place for that to help a society sort of upgrade the sort of emissions capability, determine whether any of those castings for the major components are still relevant for newer products, or even to support the others that will remain, and sort of extract those before that vehicle is destroyed at end of life. But in summary then, remanufacturing is good for the customer. Same as new performance and superior value. It's good for business. It helps us support our customers over the life cycle. And increasingly, it's good for the environment and part of our strategy for good stewardship.
Just picking up from where you ended, Todd, in terms of the connect to the end of life vehicles, you touched on something that I was thinking of exactly, which is if any country region is creating the infrastructure to bring end of life products back to some form of circular loop, there is certainly value in interjecting in there and saying, don't turn all of this back into raw material level, but try to extract value by retaining parts and components that can in fact be used in current or future models. So some of that is contingent on design. That's
sure.
Really worth kind of considering from the standpoint of where at the policy or industry level things go, what's done from a design standpoint, not just product design, but institutional design. Yeah.
Right.
Have you seen from a model's perspective, Todd, you've got sort of this bird's eye view of remanufacturing globally. What may be, it's kind of open-ended as a question, what may be nuances that you're seeing in how markets and industries and perceptions are evolving in nascent, received and developed in economies that are decades old or markets that are decades old in like the US, for example. So what might be some considerations perhaps where for consumers or even businesses that are coming into this not fully understanding but interested, and also providing that level of confidence that the product is going to perform at the same level? I think this is something that, or do you have anything you could share in terms of how that differs from emerging economies versus more developed markets?
Sure, I'll say two things real quickly. First, we have seen in different parts of the world, and we use those in our process, and we have the same, as I said, warranty and performance. And so in the U.S., in North America, remanufacturing is accepted and expected. And it's really because of those things. People, when they buy a Cummins remanufactured product, they know those things that I just said. Alternate ownership models will be relevant there as well. The nice thing, though, about a lease scenario is it predestines the return of the core. It's part of the, truly part of the plan from the beginning.
Very ambitious targets of expansion of electrified vehicles. And one terminology which is very frequently used is ecosystem. For expansion of electrified vehicles, India should have ecosystem. Ecosystem means you should have infrastructure. So what comes first, infrastructure or vehicles? This is being talked about. I will say that ecosystem also has remanufacturing as one of the major element. How? If I'm going to sell a car of say some 100 rupee, based on battery size, something like 20 to 40 rupees will go towards battery cost. After 5 years, after 3 years, if I do not know what will be the use of battery, there is one situation. But if I know after say 5 years, I can have a secondary use of battery when it becomes 80% of the performance, then I can have a third use of battery, maybe as a house inverter battery. What it means, the cost of battery, cost of vehicle to the seller will be very different. It means the total ownership cost, which is called as a sticker shock, will be much different, much lesser. As of now, new terminologies are coming for EV. It's a sticker shock. Those things will be very different. And this remanufacturing being a part of this ecosystem will expand the electrification. But second part of your question is how far it will help for the existing system. So as I was touching upon in US, for a car, if you ask somebody who has driven his car, he will say, I have run this Accord for 800,000 miles, 8 lakh kilometers. In India, if you say someone, I have run a car, 8 lakhs, he will feel either you are mad, why after 1 lakh? Why don't you change after 60,000? Because the understanding is very different. So after 300,000, a person in US will change his some portion of engine transmission and make it new, get a kind of another warranty sort of that his car is again as good as new to run. So it further helps, and to me, it makes you more competitive. Such elements should be looked into while you are thinking of becoming a global hub from a developed market. So these are, to me, these are part of ecosystem to make you successful in overall business scenario, overall competitiveness. I hope I answered to your question.
Yes, thank you. Yes, thank you. Yeah, I think you're. Yeah, it's sort of a. I understand what you're saying in terms of it being a chicken and egg kind of question, and I think in terms of electric mobility, but I think that question also applies to the acceptance of remanufactured products, not just in automotive manufacturing, but remanufactured products in general, right? If you're trying to venture into providing remanufactured products or shifting your business model where remanufacturing becomes a central or very important piece of how you're getting products out there, you've got to think about the reverse logistics and all of those infrastructure side of things. But also the question is, will consumers really go for this, right? And so it feels like an impasse, but I think it's more about you've got to lean into it a little bit, and I think that's part of what we're trying to do here through Recreate is to bridge that gap between this is a good idea, but we don't know if people will actually adopt this, and that's where the education and the sensitization and the having meaningful conversations where we're talking about it from a long-term vision perspective, but also putting numbers to it and saying, what can this look like in terms of sustainability outcomes, carbon impact outcomes, job creation potential? And to me, obviously I'm biased, but to me, this has tremendous opportunity from the standpoint of a long-term sustainable vision transitioning towards a greater degree of circularity in the automotive sector in India. And also, to your point about electric vehicle batteries, I mentioned this on the previous webinar as well, because I'd used electric vehicle batteries as an example. And this is something that I heard at an online symposium organized by the Trier University of Applied Sciences in Germany, and they were having a discussion about electric vehicle batteries. And one of the things that came up was that original designs were not designed for remanufacturability, but that has since shifted because within batteries are made up of cells or modules, and the 80% threshold that you mentioned, which is to say anything less than 80%, and it's not suitable for a car, but it can be used for stationary power storage. Well, that 80% is dependent on one cell. So if there's one cell that drops down below, which brings the overall performance down, if it's designed for remanufacturability, you could replace that one cell out, and that gives you, assuming all of the other cells are still performing at appropriate levels, you push the battery back up to a performance level where it can get used in a vehicle. So you're not necessarily giving it, it's not a, secondary usage cycle. You're talking about giving it another life cycle as its intended original design. So the discussion there was that has shifted, where battery manufacturers saying we need to go back and make these remanufacturable, because from not just from a life cycle standpoint of what the product does, but what it means from a business standpoint, from an accounting perspective. And when you start looking at, a product that is giving you multiple lives over an extended period of time versus it being on the wrong side of the ledger, so to speak, where it is now no longer what it was intended to be, and so you've got to write it off as something else. So I think there are some very real business consequences, which even Todd, you mentioned in some of the numbers that you were going through, and I think that needs to be maybe emphasized more and more. I know we're sort of coming to the end of our time here, but I have a feeling that we will have more of these conversations going forward, not just for the sake of the conversation, but I think what we would like to do is to have kind of roundtable discussions, maybe not necessarily as a webinar format, but to have a broad stakeholder base coming together who are thinking about what the future of mobility looks like, and to really kind of inject remanufacturing in there as part of the suite of strategies that need to be looked at in a meaningful way. So, yeah.
Absolutely right. Yeah.
So we are at the 5:30 p.m. mark here in Indian time. I want to thank you guys both for taking the time, for waking up very early, Todd, and also taking time out from a busy day, Yash. Do you have any last thoughts that you'd like to touch on or close with before we sign off here?
See, I would like to say a big thanks to Rajiv, because this is the topic which India needs, and maybe we have to do many interactions with the stakeholders at government side, industry association side. So you have a lot of load on your shoulders, no, to take it forward. Just to leave it as a start of this. You have to take it to a conclusion, and please do involve experts from across the globe like Todd, who have gone through this journey and can help us shortening this journey. Maybe sometimes we can secure his time even to explain this to more wider perspective of stakeholders, government officials, so that some more concrete action, policy making, regulations can be brought up here. So this is going to be one of the pillars for our economy in time to come. Thank you so much to you and to Todd for bringing this topic together.
Yes, thank you as well, Rajiv. Thank you, Rajiv, for the opportunity to talk about it, and happy to participate in future discussions. Several dimensions to the conversation, certainly for remanufacturing, and so it's good to start the dialogue.
Thank you.
I agree. Yes, I totally agree that there's more to come. So stay tuned, and thank you everyone for joining. And we'll see you next time.
All
Thanks
right.
for your time.
So long.
Thank you. Bye-bye. Bye-bye.
Take care.
Have a wonderful day.
Bye.
Thank you. Bye-bye.